Hey everyone, welcome back. Today, we are going to be diving deep into a fascinating topic. We're going to be looking at how machine learning is being used to predict diabetes.
Oh, wow.
It's going to be incredible. Our main source for this is an article.
Okay.
It's called A Comprehensive Evaluation of Diabetes Prediction Algorithms
Yeah.
Using Microsoft Azure Machine Learning Studio.
Right.
And it's by an author named Rupanshu.
Cool.
Yeah, and this deep dive, we're really going to be trying to understand
Yeah.
how effectively different machine learning algorithms can predict diabetes,
Okay.
what those algorithms are, and what the research says about their performance.
All right, cool.
And so I think we're going to uncover some really surprising results about which algorithms are kind of like the stars of the show and which ones might need a little bit more training before they're ready for prime time.
That's so cool.
Yeah,
So,
I'm really excited. Let's get started. Before we jump into the specifics of the article,
okay.
can you just give us a quick overview of what machine learning is?
Sure. So machine learning is basically a way of teaching computers to learn from data without having to explicitly program them with every single rule,
Ah, right.
right?
Okay.
So imagine you have this huge data set
Yeah.
of medical information, right?
Hmm.
You have details about people, their medical histories, their lifestyle factors, and whether or not they developed diabetes.
Okay.
And what a machine learning algorithm does is it kind of sifts through all of that data, right? It analyzes it, it identifies these patterns and correlations that would be almost impossible for a human to spot just because of the sheer volume of information.
So it's like a super detective
It is.
that can see those tiny clues
Yeah.
that we might miss
Exactly.
if we were just like reading through all the data ourselves.
It can find these subtle relationships and patterns that we as humans might overlook.
And it can use those patterns to predict
Yeah.
whether or not someone might develop diabetes in the future.
Yeah. And what's really fascinating is that, we're talking about predicting a condition like diabetes potentially before any noticeable symptoms even appear.
Yeah.
Right?
Right.
So that's the power of machine learning here, right? We're not waiting for someone to become visibly ill. We're looking at these subtle patterns and saying, hey, there's a chance this person might be at risk.
That's incredible.
Yeah.
So when we talk about machine learning in the context of predicting diabetes,
Right.
are we talking about a specific type of machine learning?
Yeah, absolutely. So there are actually different categories of machine learning. You have supervised learning, unsupervised learning, and reinforcement learning.
Okay.
But for diabetes prediction, we're primarily focused on supervised learning.
Okay, and what makes supervised learning different from the other types?
So in supervised learning, we're giving the algorithm what we call labeled data, right? So in our case, we're giving it data where we already know who has diabetes and who doesn't.
Okay, so we're kind of telling it the answer ahead of time.
Exactly, yeah. We're giving it the answer in the training data.
Right.
And the algorithm's job is to learn the relationship between the data and those labels so that it can then predict the likelihood of diabetes in new cases where we don't know the answer.
Got it. So we're kind of training it like a detective, right?
Exactly.
We're giving it solved cases
Yeah.
so it can learn the patterns and then apply those patterns to new unsolved cases.
That's a perfect analogy. It's like showing the detective a bunch of solved cases,
Yeah.
saying, here's the evidence, here's the culprit, and then letting the detective use that knowledge to solve new cases where the culprit is unknown.
And within supervised learning, are there different tasks?
Yeah, so within supervised learning,
Or are we always just trying to predict something?
there are different tasks, yeah.
Got it.
So you can do things like regression, where you're trying to predict a continuous value, like blood sugar level, right?
Okay.
But for diabetes prediction, we're really focusing on classification,
Okay.
which means we're trying to categorize someone as either diabetic or non-diabetic.
So we're basically trying to sort them into one of two buckets based
Yeah.
on the patterns that we see in the data.
Yeah, based on the data and what the algorithm has learned.
Okay, cool. Now, the article mentions that this research was conducted using Microsoft Azure Machine Learning Studio.
Yeah.
What can you tell us about this platform?
So Azure ML Studio is essentially a really powerful platform
Okay.
for building and testing machine learning models, but it's also super user-friendly.
Oh, okay.
Like it provides this really nice visual interface where you can just drag and drop different components.
Wow.
So even if you're not a coding expert, you can still use it.
That's amazing.
It's really cool.
That's like a visual programming language almost.
Yeah, almost. It's designed to be very intuitive.
Okay.
But don't let the simplicity fool you.
Right.
It's packed with all sorts of sophisticated tools for data preparation, like cleaning and transforming your data.
Yeah.
It has this huge library of algorithms to choose from and features for fine-tuning those algorithms to get the best possible performance.
So it's like a virtual laboratory for machine learning.
Exactly. You can experiment with different techniques, different data sets. You can tweak the parameters and see what works best for your particular problem.
And this is where our researchers went to put these different diabetes prediction algorithms to the test, right?
Yes, exactly.
Okay.
So the study that's described in this article, they actually evaluated 7 different algorithms to
Wow.
see which one could most accurately predict diabetes.
7. Okay.
Yeah, and they used a real-world data set
Okay.
called the PINA Indians Diabetes Database,
Okay.
which is a really common data set that's used in this type of research.
Okay, cool. So 7 algorithms
Yeah,
battling it out to see who can predict diabetes the best.
exactly. It's like a machine learning showdown.
Can you tell us a little bit more about these 7 contenders?
Sure. So we have a pretty diverse lineup here, right? We have decision forest, logistic regression, support vector machines, which is often shortened to SVM. We have neural networks,
Cool.
average perceptron, decision jungle, and Bayes point machine.
That is quite the lineup.
Yeah. Each of these algorithms has its own unique way of approaching the problem.
So it's not like a one-size-fits-all situation when it comes to choosing a machine learning algorithm.
No, not at all. Each algorithm has its own strengths and weaknesses, and the best choice really depends on the specific problem you're trying to solve and the characteristics of your data.
And out of that lineup, are there any that really stand out to you?
You know, one that always kind of grabs my attention is neural networks,
Okay.
because they're particularly interesting because they're actually inspired by the structure of the human brain,
Oh, wow.
right? So they consist of these interconnected nodes,
Yeah.
or what we call neurons,
Mm.
that process information and can learn these really complex patterns.
So it's kind of like mimicking the way our brains work.
Yeah, in a very simplified way.
That's amazing.
But it's that kind of structure that makes them so powerful, especially when you're dealing with something like diabetes, which is influenced by so many different factors, right? You have genetics, lifestyle, other health conditions.
So it's able to account for all of that complexity.
Yeah, it can kind of weave together all those different threads of information and see connections that other simpler algorithms might miss.
So it's like the master detective that can
Yeah.
really understand all the nuances of the case and
Yeah.
put all the pieces together.
And neural networks have shown a lot of promise in predicting complex conditions like diabetes.
Okay, that's really cool.
Yeah.
So before we jump into how these algorithms actually performed, can you tell us a little bit more about the methodology that the researchers used in this study?
Sure. So basically, they took this data set, the Pima Indians Diabetes Database,
Okay.
and they did a bunch of pre-processing, which means they kind of cleaned up the data, made sure there weren't any missing values, and they might have transformed some of the variables
Okay.
to make them more suitable for the algorithms.
So kind of getting the data ready for the algorithms to analyze?
Yeah, exactly. It's like setting the table before you serve the meal.
God, okay.
And then they split the data into 2 sets, a training set and a testing set.
Okay, and what's the difference between those two?
So the training set is used to, well, train the algorithm.
Okay.
It's like giving the detective those solved cases
Right.
so that they can learn the patterns.
Got it.
And then the testing set is used to evaluate how well the algorithm has learned, right?
Okay.
So it's like giving the detective a new case.
The brand new case.
Yeah, and seeing if they can correctly identify the culprit based on what they've learned from the training data.
Okay, and they mentioned something called tenfold cross-validation.
Yes, so that's a really cool technique.
Okay.
That's used to make sure that the results are reliable, and it helps to avoid any flukes.
Okay, cool. So can you explain what that means?
Yeah, so basically they take the data and they split it into 10 parts.
Okay.
And then they train the model on 9 of those parts and test it on the remaining part.
Okay.
And they do this 10 times,
Okay.
each time, using a different part for testing.
So they're kind of rotating which part of the data is used for testing each time.
Exactly, yeah.
Yeah.
So it's like giving the algorithm 10 different practice tests to make sure it's really learned the material.
I love that. That's a great way to put it.
Yeah, and it makes sure that the results aren't just due to chance or some quirk in the data.
So we can be more confident that the algorithm is actually learning something meaningful
Exactly.
and that it can generalize to new data that it hasn't seen before.
Yes, that's the key.
That's really cool.
Yeah.
So we've got our algorithms.
Yeah,
We've got our data.
we do.
We've got our training and testing sets.
Yeah,
And we've got this really rigorous way of evaluating the algorithms.
absolutely.
But how do we actually measure which algorithm did the best job?
Right. That's where the evaluation metrics come in.
Okay.
Think of them as like the scorecards for our algorithm.
I like it. Okay.
Right. We need a way to quantify how well they're doing.
Yeah, we need to see who's winning this competition.
Exactly. We need to see who's coming out on top.
Okay, so what were the key metrics that they used to kind of crown the diabetes prediction champion?
So there are 5 main metrics that they used:
Okay.
accuracy, precision, recall, F1 score, and ROC-AUC.
Okay, so 5 different ways of measuring
Yeah.
how well the algorithms are doing.
Exactly. And they each provide a slightly different perspective on the algorithm's performance.
Okay, well, let's start with accuracy.
Okay.
That seems like a pretty straightforward one.
Yeah, it's the most intuitive one.
Mm.
Accuracy simply measures the percentage of correct predictions made by the algorithm.
Okay, so if the algorithm correctly classifies 80 out of 100 people,
Yeah.
it would have an accuracy of 80%.
Exactly.
Okay, easy enough. What about precision?
So precision is all about minimizing false positives.
Okay.
Right. So in this context, a false positive would be like incorrectly classifying someone as diabetic when they're actually not.
Okay, so it's like crying wolf.
Yeah, kind of. You don't want to be raising the alarm when there's no real threat.
Right.
So precision tells us how good the algorithm is at avoiding those mistakes.
Okay, so if an algorithm has really high precision,
Yeah.
we can be more confident that when it says someone is likely to develop diabetes,
Yeah.
it's probably right.
Exactly. It means the algorithm's being very careful and only making positive predictions when it's really sure.
Okay, that makes sense. But what about the cases where the algorithm might miss someone who actually does have diabetes?
Right. So that's where recall comes in.
Okay.
Recall, which is also sometimes called sensitivity.
Okay.
It's all about minimizing false negatives.
Okay, so that's the opposite of a false positive.
Yeah, exactly. A false negative would be missing a case where someone actually does have diabetes.
Okay, so it's about making sure that no one slips through the cracks.
Yes, exactly.
Yeah.
You want to make sure you're catching as many true cases as possible.
So it's kind of like a trade-off between precision and recall, right?
Yeah, there's often a bit of a balancing act. Because if you try to increase one,
Yeah.
you might end up decreasing the other.
So if you want to catch all the cases of diabetes,
Yeah,
you might end up flagging some people who don't actually have it.
exactly. And that's why it's important to look at both metrics together to get a complete picture.
Okay, that makes sense. What about the F1 score?
So the F1 score is a really handy way to combine precision and recall into a single metric.
Okay.
It's what we call the harmonic mean of the two,
Okay.
which basically means it gives us a balanced view of how well the algorithm is performing overall.
So it's kind of like a weighted average.
Yeah, you can think of it that way.
That takes both into account.
Exactly.
Okay, cool.
Right.
And then the last one you mentioned was ROC-AUC.
Yeah, that one's a bit more nuanced,
Okay.
but it's a really powerful way to assess the overall performance of a classification model.
Okay, can you try to explain that one in a way that even I can understand?
Okay, so imagine a graph
Okay.
where the x-axis represents the false positive rate,
Oh.
and the y-axis represents the true positive rate.
All right.
The ROC curve, it basically plots these rates for different thresholds that are used by the algorithm.
Okay.
And AUC, which stands for area under the curve,
Yeah.
is simply the area under that curve.
Okay.
So a higher AUC generally means that the algorithm is better at distinguishing between the two classes.
So in our case, diabetic and non-diabetic.
Exactly.
Okay, so it's basically like a visual representation of how well the algorithm can separate the people who have diabetes from the people who don't.
Yes.
Okay, that makes sense. So we have these 5 key metrics: accuracy, precision, recall, F1 score, and ROC-AUC.
Yeah.
To help us evaluate these 7 contenders in our diabetes prediction challenge.
It's going to be an exciting competition.
I can't wait to see who comes out on top, but we'll have to wait for the next part of our deep dive to find out.
Stay tuned.
All right, see you then.
See ya.
All right, the anticipation is killing me. Let's get to those scores. Which algorithm emerged as the champion?
Well, the results are really interesting. It turns out, like we kind of thought, some algorithms were definitely better at predicting diabetes than others.
Oh, okay.
And the two-class neural network, as we kind of anticipated,
Yeah.
it performed exceptionally well.
I knew it.
I know, right? Like those neural networks,
It's so cool.
they're really something special.
What kind of scores did it get?
Well, it actually achieved the highest AUC score,
Okay.
reaching an impressive 0.810.
Wow, that's pretty high.
Yeah, it is. And what that means is it had a really remarkable ability to differentiate between individuals with and without diabetes.
So it really could tell the difference.
It could. And it's a reflection of its deep understanding, right?
Yeah.
Of all those complex factors that play into diabetes risk.
So like we were saying before, it's really like a master detective
Is
that can uncover all those hidden patterns
absolutely, yeah.
that are in the data.
And connect the dots that we might miss.
That's amazing.
It's really impressive.
Okay, so the neural network definitely crushed it in terms of AUC, but what about the other algorithms? How did they do in comparison?
Well, if we look at accuracy, which remember, that's the overall percentage of correct predictions, we actually see a tie for first place
Oh, interesting.
between the two-class logistic regression and the two-class average perceptron.
Okay.
Both of them achieved a score of 0.786.
So even though the neural network was really good at like distinguishing
Yeah.
between the two groups, it wasn't necessarily the most accurate overall.
Well, it was really good at distinguishing, right?
Yeah.
Like separating those two groups.
Yeah.
But in terms of just like raw accuracy, the logistic regression and the average perceptron were a little bit better.
It's like they had a slightly different approach to the problem.
Exactly. And that's what makes this research so fascinating, right?
Yeah.
It really highlights that the choice of algorithm can significantly impact the results. Each algorithm kind of brings its own strengths to the table, and the best choice might depend on, what are you actually trying to achieve with your prediction?
Right. So there's no one perfect algorithm for every situation.
No, definitely not.
It's about choosing the right tool for the job.
Absolutely, yeah.
Okay, so we've got our winners, or I guess we have our top three.
Yeah, we have podium, right?
But were there any algorithms that really struggled to keep up? Like any that might need to go back to, algorithm school for some extra training?
Yeah, there was one algorithm that consistently underperformed across all of the metrics.
Oh, no.
Yeah, and that was the two-class decision forest.
Okay.
It's actually a simpler model,
Oh, okay.
but it just couldn't keep up with the complexity of the data and all the different factors that influence diabetes risk.
So it seems like in this case, complexity was key, right? Like those more sophisticated algorithms like the neural network really had an advantage when it came to unraveling the mystery of diabetes prediction.
Yeah, I think that's a really good point.
Yeah.
It highlights that when you're dealing with something as complex as a medical condition, like diabetes, right?
Yeah.
Which has so many different influences, sometimes those simpler models just aren't enough.
They can't capture all the nuance?
No, it's like trying to solve a really complicated puzzle with like a simple tool, right?
Totally.
You need the right tools for the job, and in this case, those more complex algorithms seem to be a better fit for that complexity.
That's a great analogy.
Yeah.
Okay, so we've talked a lot about these algorithms and how they performed, but what does all this mean for, like, the average person? Why should someone listening to this care about which algorithm predicts diabetes the best?
Well, that's where it gets really exciting, right?
Okay.
Imagine a future where your doctor can use these algorithms to assess your individual risk of developing diabetes.
Wow.
We're talking about early detection, personalized prevention plans, and potentially even like delaying or preventing the onset of the disease altogether.
That would be incredible, like a game changer.
It would be revolutionary.
Yeah.
It really would.
It's like having a personalized crystal ball.
Yeah, like a glimpse into your future health.
Yeah.
And it can help guide you.
Instead of waiting for symptoms to appear,
Exactly.
you can take steps now to lower your risk.
Exactly. You can be proactive.
That's so cool.
And it goes beyond diabetes, right?
Yeah.
This type of research paves the way for using machine learning to predict and manage all sorts of health conditions.
Oh, wow.
So it's like the tip of the iceberg.
Like a whole new era of healthcare is opening up.
Exactly. Yeah.
That's so exciting.
It's a really exciting time.
It is.
And it's a powerful reminder that data, when used thoughtfully and ethically,
Yeah.
right,
Yeah.
can have a huge impact on people's lives.
I completely agree.
It's amazing to see how technology and healthcare are coming together to create a healthier future for all of us.
It really is.
It's super cool.
So we've got this powerful new tool, but like with any tool,
Yeah.
we need to make sure we're using it responsibly and ethically.
Yeah, as we get more and more into this,
Yeah.
we got to remember that these algorithms, they're tools, right?
They are.
And they can provide incredible insights.
Yeah.
But they're only as good as the data they're trained on, and they still need human expertise to be used properly.
That's a great point. It's not about replacing doctors with algorithms.
Right.
It's about giving doctors more information.
Exactly.
Okay, so before we move on, can we dive a little deeper into those other metrics you mentioned, like precision, recall, and the F1 score?
Yeah, absolutely. I think it's worth taking a closer look at those.
All right, so let's break down those other metrics, precision, recall, and the F1 score. I think those are really important for getting like the whole picture of how these algorithms stack up.
Yeah, they could give us a more nuanced view, right?
Totally.
So if we look at precision first, Remember, that's how well an algorithm avoids those false positives.
Yeah.
The two-class logistic regression, it actually takes the lead here with a score of 0.710,
Wow.
which means it was really, really good at avoiding, incorrectly classifying someone as diabetic when they weren't.
So logistic regression was kind of playing it safe.
Yeah.
Making sure it had strong evidence before flagging someone as potentially at risk.
It was being cautious.
I like that. I like that cautious approach. But what about recall, right?
Yeah.
Like the ability to catch those true diabetes cases.
Right. So when it comes to recall, the two-class neural network, it really kind of stole the show here.
Okay.
It achieved a score of 0.630, which means it was the most effective at identifying individuals who truly had diabetes.
So it was a little bit more like vigilant,
Yeah.
casting a wider net.
It was more sensitive, right?
Okay.
It didn't want to miss any potential cases.
Even if it meant maybe flagging a few more false positives along the way.
Exactly.
It's interesting, right? It's like this balance between the two.
It is, yeah.
You don't want to miss anyone,
Yeah.
but you also don't want to, worry people unnecessarily.
Right. You want to find that sweet spot
Yeah, exactly.
where you're being thorough but also accurate.
So how did they do on the F1 score, right? That was the one that kind of combined both of those together.
Right. The F1 score, remember, that gives us that balanced view. And in this case, the two-class average perceptron, that emerged as the most balanced model
Correct.
with an F1 score of 0.621.
So it was kind of like the Goldilocks, right? Not
Yeah.
too hot, not too cold. It did a good job at both minimizing those false positives, not crying wolf too often,
Well-
and then also catching those true cases.
Yeah, it was like the best of both worlds.
Yeah.
Found that balance.
It's amazing how they all kind of, they've cut their own little quirks and strengths and weaknesses.
Dude, yeah.
And when you put them all together, you get a much more complete understanding of someone's risk for diabetes.
Absolutely. It's like having a whole team of detectives, right?
Totally.
Each with their own specialty,
Yeah.
working together to solve the case.
Love that analogy.
And it really highlights the importance of choosing the right algorithm for the job.
Right. There's no
One size fits all in the world of machine learning.
no magic bullet.
Yes.
It really depends on what you're trying to achieve.
I mean, taking a step back for a second, this is all pretty mind-blowing, right? We've got these algorithms that can analyze all this complex medical data, identify these subtle patterns, predict the likelihood of developing diabetes with, a pretty remarkable level of accuracy.
Yeah, it's incredible what we can do with data these days.
What does this mean for the future of healthcare?
Oh, it's so exciting to think about.
What possibilities does this unlock?
Well, I think we're on the verge of a huge paradigm shift in healthcare, right?
Yeah.
We're moving from this reactive approach of treating illness to a much more proactive approach of preventing it.
Wow, that would be amazing.
Imagine a world where we can use these algorithms to identify people who are at high risk, not just for diabetes, but for heart disease, cancer, Alzheimer's,
Oh, wow.
all these different conditions.
And we could intervene earlier.
Exactly. And maybe even prevent them from developing the condition altogether.
Potentially, yeah.
It's almost like a personalized health roadmap.
It is, yeah. It's like having this guide.
Instead of waiting for things to go wrong, you can take steps now to stay healthy.
Exactly, you're empowered.
It's so cool.
And it's not just about living longer, right?
No.
It's about living better, having more healthy years.
Quality of life, yeah.
It's really about improving that health span, making sure those years are good ones.
That's a great way to put it.
It's about well-being, not just treating illness.
I love that vision of the future, where technology and healthcare come together to create a healthier world.
Yeah, it's a beautiful vision.
But, like you said before, we have to make sure we're using this technology responsibly,
Absolutely, yeah.
ethically,
It's a powerful tool.
Yeah.
And with great power comes great responsibility.
We got to make sure these algorithms are free from bias, that they protect people's privacy, and that they're being used to empower people, not to discriminate against them.
That's so important.
Yeah.
We have to be mindful of those ethical considerations.
Okay, well, I think that about wraps up our deep dive into the world of diabetes prediction using machine learning.
It's been quite a journey.
It has. We've learned about different algorithms. We've looked at how they performed. We've even talked about the ethical implications.
Yeah, it's been a great discussion.
But as always, we like to leave our listeners with something to ponder, right? Something to think about after the episode is over.
Always got to leave them with a question.
So here it is. We've seen how effective these algorithms can be at predicting diabetes, but what other applications of machine learning in healthcare do you think hold the most promise?
That's a great question.
And what other ethical considerations do we need to keep in mind as we continue to develop these
Those
technologies?
are really important things to think about.
So, to all our listeners out there, keep those brain gears turning and join us next time for another deep dive into the world of cutting edge research. Until then, stay curious.
See you next time.